Thank you, thank you, thank you. Back from a power plant visit last week. That went great. The facility was awesome out in California. It was not running, believe it or not. There was a battery energy storage system right next door, and this was a peaker facility, and they really didn't need to peak. The solar plants and the battery systems were maintaining the load, at least during the time that I was there. But today you clicked on mechanical integrity for energy risk engineers. We're going to talk about that, right? Let's get going. So, yeah, it's time for more integrity, right? Let's see what else is going on in the world. We've got, pipes rusting and flanges coming apart. Some of the reason that your flanges might be leaking is you're insulating them. So be careful if they're hot flanges that you want to look into that specifically before you go ahead and insulate them. Just some more leaks. We got to be careful about what we're doing in our process. Fortunately, most of this looks like water, but as we know, we have some solvents and hydrocarbons and some toxic products that we handle. So even on new equipment, we're seeing leaks, and we have to manage how we approach the entire mechanical integrity process. What is mechanical integrity? Well, it's the process where we maintain all of the critical equipment, everything that's important for the facility, and make sure that it's installed, operated, maintained correctly. Okay, and designed. So that's it, basically, that we're going to just make sure we do it right. Okay, but why? Let's see. Well, one of the reasons is that safety. If you have safe equipment, if you have properly operating equipment, it's going to be safer to be around. If your equipment isn't failing at 2 in the morning and you have to call in crews for emergency work and they're coming into the dark, it's going to be a lot safer during the day when you can plan the job and have all the tools and resources necessary to get the job done and they don't feel rushed. Reliability, right? Well, if you're regularly inspecting the material, the equipment, you'll catch the problems before they erupt into catastrophe. So reliability is improved by mechanical integrity programs. Compliance, not something I'll talk a whole lot about. It doesn't really rear its head in the risk world. It's something that the regulators use, but risk engineers don't rely on regulations. We rely on real world cost benefit analysis based on risk. Okay, if you're using regulations, you're tending down the lazy path. You've got to convince people that they need to do things that are in their interest, not that the code tells them that they have to do. What else do we get? We get cost savings. When we're doing it right, we're not failing, and we're not coming in the middle of the night paying overtime, we're going to save money for operating the plant right. How do we do it? Well, we're going to have to create some sort of inventory. We're going to have to know what all of our equipment is. We're going to have to give it ID numbers. We're going to have to create a system that tells us all the detailed equipment information so that if we need to replace it, we can. If there are campaigns from the manufacturer that involve recalls or defects or repairs, we want to know what equipment we have and if it's related to those campaigns. Asset management software is awesome for this because you can have everything in there and you can get trending and you can get warnings, you can get information to go out and maintain your equipment. So software is the way to go. We'll talk more about digitization of mechanical integrity as we go on. Risk-based inspections, okay? What is a risk-based inspection? Well, we're going to look at equipment often enough to keep it from failing at a frequency that interrupts us or a frequency that's unacceptable. And that's what the risk part of it's about. In a compliance world, you're going to do it because the regulators say it has to be done once per year. You may find financially that it's more economical to do it 4 times per year. You're allowed to do that. It's up to you if you're doing a risk-based assessment. You may find that it's once every 5 years, but until you do the assessment, you don't know which way that frequency is going to go. All right, what are in the risk-based inspection? We're going to have to do an assessment of the risk. And when we do that, remember, risk is the likelihood times the consequence. So we're going to go out and look for things that either have a high likelihood or a high consequence, and that's what we're going to assess as higher risk. We're going to plan our inspections. The higher risk equipment is going to get looked at more often. We're going to do the inspections, and the people that are doing it are going to know what they're looking at. They're going to be trained to look for the problems, not just to fill out a piece of paper. Next, we're going to do data analysis and risk reassessment. So this is where all of that documentation gets looked at by higher levels, maybe other engineers that are responsible for the entire program versus the QA or QC folks that actually did the inspection. And then we have to have documentation. I'll tell you some stories about documentation, but it helps immensely to know how a piece of equipment has been maintained, repaired, installed in order to do the future repairs and fixes. Not that you'll repeat them, but you gain some information based on the history that'll help shape your future repair work. Alrighty. Next, we're going to plan the inspection, testing, preventative maintenance program to keep things from failing now that we know what's out there and what's important. And what's in a big ITMP program, the inspection, testing, maintenance, preventative maintenance program, PM, not MP. So you look at everything that's visual. There's non-destructive examinations. You're not breaking or cutting anything. Testing, that's when you put equipment or systems under pressure tests, functional tests, performance tests. You're looking to see what kind of flow rates, what kind of output you can get from the system. Preventative part of the maintenance, you're cleaning things, lubricating them, you're making adjustments. And again, we're collecting data, documenting when we did it, how often we did it, if there was corrective action involved. So if we find something wrong with the inspections, we've got to follow up with corrective action. The documentation has to tie all that together, because the documentation really includes everything from the initial procedure and the inspection checklist or protocol that you're going to use, the training programs, all the way down to the actual what did we see and how does it look. So documentation's hugely important. What else is important for an MI program? Quality assurance and quality control. And let's talk about what quality assurance and quality control are. It starts with standards and procedures. You give your employees the right to operate the equipment and the authority to do that based on the procedures that they have. They're not to operate the plant outside of the procedures. That's management's permission to the employees to operate the plant, but only within the bounds of those procedures. And the standards are what come from either internal or external groups, but they help shape and mold what you're going to audit to, what your assurance of quality is going to be based on. Then we're going to train people. We're going to train the workers. We're going to train the inspectors. We're going to make sure that people that are inspecting the work actually know what they're looking at. We don't want someone inspecting a weld who's never seen a weld before. So we're going to train them on how to inspect and test. We're going to manage quality of materials. We're going to make sure that we use a positive material identification gun, PMI gun, when we have something that's a special alloy. We want to make sure before we put it in the warehouse that we know what it is before it goes in. Then nonconformance management. When we have something wrong, when we detect something with this inspection program, and there's something wrong, we have to have some system that manages the nonconformances. And the problem with nonconformances is that they're nonconforming because there's something that might impact operations, or they didn't know about it. If they knew about it and they're not doing anything about it, that's where you're going to have a little work cut out in order to get something done about it. Other than that, we want to point out the problems and get them resolved. So, what else? Corrective action maintenance. That's the getting it resolved part. It does you no good to find the problems if you don't fix them. We'll talk about some lessons learned coming up. There were some events out in industry that were related to failures of mechanical integrity programs. We'll bring those up and we'll talk about the lessons learned, and corrective action management was very important in some of them. Documentation and record keeping. Give you an example. I used to work in a nuclear power plant. I was responsible at one time for the valve program. We were repacking and putting in live load packing on our main big steam line valves. But the problem was that we had a lot of packing leaks in smaller valves. And when we went out to repair the packing leaks, the first thought was just tighten the packing. They do that until the gland follower bottoms out, and then they pull the gland follower out, stuff in more rings of packing, and start the cycle over again. They never were pulling the old packing rings out. Well, where do you think all that crap was going? Down into the steam system, which was into our cooling water system. So that was causing a source of contamination in the water that got radioactive. So it wasn't good to be pushing all that crap down there. Without documentation, we'd have no idea that that was occurring. With documentation, the future group would see that we pulled all the packing out, we put brand new rings in, and guess what? They're not having to go back out there and repack this valve, just top off the stuffing box, all based on documentation and record keeping. Training. I can't tell you how many times that we've seen people who are trying to do something that they're not trained for, or worse, it's sad to see risk engineers thrown out into a facility and, say they've never done a process hazard analysis. Believe it or not, there's some out there. Depends on what career, what choice or path you take, where you'll end up, whether you're even involved with PSM. But if you're in risk engineering in the energy field, chances are you're going to be involved with PSM. Even in power gen, they've got ammonia and chlorine issues that can drive PSM. Sometimes the fuel that they have can do it too. We've got to train people to know what they're looking for and how to find something wrong. We're going to look at performance metrics and continuous improvement. One of our clients does an awesome job. They built their own little system to go out in their plants, and they pulled together about 20 criteria, and they've got a rating scale for everything that they want to demonstrate that a plant is doing to improve and get better. And they've got like 6 refineries, and the whole point is that they don't want to keep throwing money at the plant that's already doing great. They want to make sure that the resources are being spent where they're needed most. So by looking at everything across the board and comparing them, they can then see this is where we need to improve our mechanical integrity program. All right. We want to have a prioritization of resources. When we're looking at a risk-based system, we've already said that it's going to tell us the things that happen often or cost a lot when they happen. So let's prioritize what we're doing about it. And that's exactly what a risk-based inspection program will do for us. Help us fix the things that matter the most first, not the thing that just broke. Risk management, it's inherent, right? If you're looking at what matters most, you're managing risk. Inspection planning, it helps in an RBI system for planning the inspections to work around your equipment. You have to worry about outages or shutdowns, turnarounds. Different industries call them different words for the same thing, basically for either repairing, regenerating, getting the unit back ready to run again. But that's part of the thing of inspection planning, is that you can't just do a once a year inspection all the time, because the equipment may not be available. It may be part of an entire process that's not available for whatever reasons. Risk-based inspections are cost effective because we're not wasting money just doing the same thing to everything, even the equipment that's not important versus the equipment that is important. So it's very cost effective. We're highlighting what matters most. We're going to improve safety and reliability in a risk-based inspection program, again, because we are fixing the equipment that needs to be fixed, we're looking for problems, and we're dealing with it. Now, I'm going to take a little sidebar. We're going to go into the Chemical Safety Board website, CSB, and this is the link if you have a way to cut and paste it, but let me get you over there and show you what it looks like. All right. Now, for those of you who recall some of my older videos, we actually went to Bing, and that which is built into Edge. And if you look over here on this top right, see that little button, you click that, and now you still got your website, and it's got all these stories about what happened in these events, and you can say generate page summary. Boom, it will then just summarize that entire page. You don't have to read it all. What if you wanted to know, were there lessons learned from these events? What were the lessons learned? Well, boom, there it goes, and it starts showing you what the lessons learned, right? So that's just to give you an idea of, what the Bing chat AI can do for you to help you get through a lot of research when you're trying to understand and learn some information. So back from the CSB, what were those lessons learned? Let's go back to front and slides. Here we are. So sulfur corrosion. At the Chevron incident, they basically had problems inspecting the carbon steel components. At the carbide industries in Marcus Shales, they had equipment maintenance. They had temporary fixes over necessary replacements. At the Motiva and DSP Enterprises accidents, implementation of recommendations. Here it is again. They're inspecting, they have a corrective action recommendation, but they didn't implement it, so they fell victim to it, which is the worst kind of incident to have, is one that you could have prevented. an inherently safer design. At the Silver Eagle and BP Texas refinery accidents, the drum relief line was not connected to the flare system, so it just blew hydrocarbons out that eventually caught on fire, exploded. So what is the role of the underwriter and the risk engineer in mechanical integrity? You're going to be reviewing the program. So what is that? You're going to look at the documentation. What is the overall procedure or guiding document for the industry, say, or for that facility, say? And then you're going to drill down into the documentation of the training of the employees, of the specific procedures that were done on the critical equipment. Then we're going to look at compliance for a little while, because there's some things that if they're fully not compliant with codes and standards, that'll show very quickly. But risk engineers don't generally get involved with compliance inspections. Risk-based analysis, we're going to do the audit. So if the underwriter or risk engineer is looking at an MI program, they want to see how was that risk analyzed. They want to see what were the assumptions, what were the frequencies, what were the high values. This whole risk-based analysis gives you a chance to see what's important, and that's what the risk engineers and the underwriters need to do. And then we're going to have site visits, right? They go great, especially if the folks who are looking at your program know what they're looking for. So hopefully the risk engineers that are the folks that are chemical and process engineers that want to be risk engineers, you're getting something out of this training that we're putting together. And then we're going to assess the training and competency. I've actually seen inspectors talk to employees and ask them easy questions, but just questions to kind of find out, how often they get trained, how comfortable they are with the training. Is it acceptable? Do they need any help? Is there anything else they would like? All right, now we're going to talk about the latest technologies in mechanical integrity. Digital twin technology. This is where we basically laser map or 3D model our facility, and it's phenomenal for being able to later walk through virtually and see where equipment is and determine if there's a problem, or if you're going to do an inspection, you can sort of plan scaffolding and what you'll need to get out and do that inspection before you get there. So what else is out there? Ammonia cracking. They're looking at ways to crack ammonia to make hydrogen, and that's going to improve processes. We're looking at nanotube technology using carbon and making extremely strong material that's very lightweight. It's going to improve sensors and the actual components that we use in our processes to start with. What else? Ethanol to propylene. This is something that's going to take us from 3 steps to 1 step, and we're not going to have the same mechanical integrity issues as we did with 3-step processes. And lastly, we're going to have a scalable MI programs. What is scalable? Holistic, it's got to cover everything. Adaptable means that if the technology changes, your system has to be able to change with it. And then sustainable. It has to be something that you don't just put all the data in once and then that's it. It has to be something that is continuously updated and is accurate, because if it's not accurate, folks aren't going to use it or believe it. So it's got to be holistic, applicable, adaptable, and sustainable. Here's some regulatory standards that apply to MI programs for folks that are interested in regulations. All right, the future of MI, it's got to be scalable, digital. We're going to keep up with emerging technologies, pay attention to regulatory changes, and be ready to keep our equipment safe and reliable. With that, thanks for staying, and please comment. See y'all later.